Hey guys, so I have a red factory over here and a green factory over here. I need to get stuff from my red factory to my green factory. But there's this body of water in the middle that's 6 miles across right here. And this distance right here is 8 miles. So I can make a bridge across the body of water, and that's going to cost me $40,000 per mile for the bridge. And then I can build a road all the way to the green factory, and that's going to cost me $20,000 per mile for the road. So if I did that, let's find out how much it would cost. First, we have the 6 miles times the $40,000, and then the 8 miles times the $20,000. And that adds up to $400,000. But I have options. I could also do this, cut straight across through the water. And this makes a right triangle so I can find out how far C is by doing A squared plus B squared equals C squared. And we get C equal to 10. Let's change that up here. Now let's see how much this route would cost. It's going to be 10 miles times the 40,000 for a bridge. That is also $400,000. So either the orange route or the yellow route will both cost me $400,000. Let's try something in the middle. I'm going to choose the point exactly in the middle so that it's 4 miles on either side of the dot. I'll connect the red factory to that dot and then go to the green factory. And let's find out how much this would cost. Well, the road part's easy. It's just the 4 miles times the $20,000. The bridge is a little bit trickier. Let's call it pink C, and let's do another Pythagorean theorem. So the A squared will be 4 squared and the B squared will be 6 squared, and that's equal to C squared. And we get C is equal to the square root of 52. So we can change that up here, and we can also update our calculations to give us root 52 times 40,000. All of this sums to about $368,444.10. So it would be more efficient to aim for the spot right in the middle. But let's find the spot that costs the least amount of money. We're going to pick a random pink dot this time. And we'll call this distance right here X, and then the rest of this would be 8 minus X. We want to find the value of X that makes this pink path the lowest possible cost. Let's calculate the cost. The road is going to be 8 minus X times 20,000, and then 40,000 times the length of the bridge, but we don't know that at the moment. Let's do another right triangle. So we'll have an A squared plus B squared equals C squared. So the A squared will be X squared, the B squared will be 6 squared, and the question mark will be the C, so let's change that question mark to C. 6 squared is equal to 36, square root both sides. We get C is equal to the square root of X squared plus 36. And let's update the C here, here, and get rid of this. This right here is our total cost once we know what X is. So let's make it a function in terms of X. So there's two ways for us to solve this. First, we could just graph it and find where the minimum occurs. So here's the graph of the function right here, and if we just click on it, it'll show us the minimum is 3.464. And when X equals that, it's going to end up costing us about $367,846.10. And any movement to the right or left is going to end up costing us more. So now we found when our minimum will occur. It's when X is equal to this, and the whole project will cost us about this much money. And for those of you who know calculus, this can be done without a calculator. Honestly, the only part that you might even want to use a calculator for is knowing that the square root of 12 is approximately 3.46. Let's update our visual. This X is 3.464. That'll make this piece 4.536. So in conclusion, to get the minimum cost, we should make a bridge from the red factory to the point that is 4.536 miles from the green factory. How exciting.